Let's look at an example where we take a data set and come up with a rate law from it. For those of you trying to do this in lab, I'm going to intentionally not plug any numbers in until the very end to help you with setting up your Excel equation. You'll just have to figure out which cells in Excel represent each of these numbers, then you can put that into an Excel equation. Doing this all at once, so there will be we'll have a few logarithms in it, but it'll be okay. So let's first ask a question. For this data set, I'm going to calculate the rate law, the rate order for B. I'm not going to worry about A, you can do that on your own. Let's just look at B for now. For something like lab or an assignment, you'd probably have to do both. But okay, what I need to do to be able to find the rate order for B is I need to find a set of trials where A doesn't change and B does. So see, if we do trial 1 and trial 2, this doesn't work well because our A concentration is increasing, but our B stays the same. So when we try to manipulate the rate laws, our B's will end up canceling out. Similarly, trial 1 with trial 3 won't do well because both A and B change at the same time. So that's not going to be able to work that. So I'm going to choose trials 2 and 3 here. And so what we're going to do mathematically is we're going to divide one of these trials by the others. So first, let's just try writing out one of the rate laws. So for example, the rate for trial 3 is going to be equal to K, a rate constant, times A to the M power, or I guess in lab you call it the X power. So let's say A to the X, and then you'll have B to the Y power. And each of these will be the values for trial 3. Note that it doesn't matter what letters you put up top here. It can be M and N like your textbook uses, lab uses X and Y, any set. I just recommend not using the letter O because it looks like a 0, and I guess L because it looks like a 1. But other than that, just pick 2 letters, it doesn't matter. And then similarly, we have rate 2 is equal to K, and in this case, because we're not changing temperature or anything, K should be the same thing. And then we have A, with the value at 2 to the X, times B to the Y at 2. So note, these rate values are just going to come from here. And then the A and B, clearly we have A's and B's. So we can plug these in. Note in lab, it doesn't say molarity here, and that's okay. You're doing relative concentrations. And you'll see when you plug these in, that you end up canceling out all the units, whatever they would happen to be. So you don't have to worry about it as long as they're in the same units. So let's take one of these and divide by the others. It doesn't matter what order you do it in, but I'm going to do rate 3 divided by rate 2. And that means this is going to be equal to, on top, K times A3 to the X and B3 to the Y all over K A2 to the X B to the Y 2. So we can already see these K's are going to cancel out. So that means they go away. We don't have to worry about them. The next thing we should note, if we go up here, A2 equals A3. So we know A2 equals A3. Since these are identical to each other, they can cancel each other out because this would just be 0.2 to the X over 0.2 to the X. So these are going to cancel as well. Remember, that just means they go to 1, but B3 and B2 are different, so we can't cancel those out. So now we have rate 3 over rate 2. And remember, these are numbers. I'm just leaving it like this for the algebra to help you set up your Excel equations. So we have B3 to the Y, and then we have B2 to the Y. So now I'm going to use my exponent rules to make some changes to this here. What I know is I can rewrite this as B3 over B2 all to the Y power. Now the next step I'm going to do is, see, we've got this Y in our exponent. We want to get Y out in front so I can be able to actually calculate it. I don't know how to do it just from my exponent. So I'm going to take a logarithm of both sides of my equation. Note that you can take the ln or the log, it doesn't matter. We're not using it to cancel out an e or a 10 or anything, so it doesn't matter which base your logarithm is in. And technically you could use any base, but I'm just going to choose log 10, which is just written as log. So now we have that log of rate 3 over rate 2 is equal to the y, I won't do this first. We'll do that step separate. Log B3 over B2 to the y. Now, one of the helpful things is your rules of logs means we can take this exponent and put it back in front of our logarithm. So that means we're going to have this is equal to y log B3 over B2. So now we want to solve for y. So I'm going to take my log... where'd my pen go? It disappeared on my screen. There we go. So this log 3 over rate 2, that's over here. We just need to divide by this term over here. Because if we divide by this, then y will be left over, and we'll have it by itself. So we're going to get that y is equal to, in the numerator, we have log rate 3 over rate 2, because that was on our left side. And then we're going to divide it by log of b3 over b2. So remember, rate 3, rate 2, b3, and b2 are all numbers we've measured. They all come from our table. So as a reminder, this is b2, this is b3, this is rate 2, this is rate 3. So you could actually put an equation into Excel to do this. I'm going to plug these numbers into my calculator now. So we've got... And when I do that, I'm going to get that y is equal to 0.974. And remember, we're going to assume our rate orders are integers. We're not going to deal with like square root rate laws when we're trying to calculate these, although those can't exist. We're just going to go with it's our closest integer. So 0.974 rounds to 1. So that means we are going to get that y is equal to 1. You could then solve for x, and if you do the same thing, you'll get that x is equal to 0, which means that my rate law, I know I'm writing at the top, is going to be equal to k times b, and that's just to the first power. Note that if you needed, you could also solve for k and get a value for that. So if you want the complete rate law, you'll also need to mathematically solve for k. You do that by just choosing one of your b's and one of your rates. Since you only have two variables now, if you plug those both in, you can solve for your constant. But this would be the general rate law without solving for k, and then you can then finish by solving for k. So you'll notice that I know that there's some terms here that look a little weird, like especially when you get to where you've got like 4 different numbers and 2 logarithms, but these are all numbers you've actually had before. I also want to remind you, for those of you using Excel, that when you get this 0.974, you'd like to round it. So what you can do is you can actually use a round function, which is just capital R-O-U-N-D, and then put in parentheses whatever it is you want to round. So you can plug all of this stuff here, the y, into a round function, and that'll do that for you. It's also okay if you don't do that part, but that would help out so that it makes it so you already have your answer. You can even set it up to just show you your entire rate law from that. Because your rate law is, we're not going to say your rate order is 0.974. We're going to say your rate order is 1 in this case. It's a first order reaction. So I know there are a bunch of steps to these, but hopefully that helps out a little bit.